This is an update to Itchbots, the robot interface for Scratch. This is the robot that I'm currently using, Marvin. And this is the interface into Scratch. So the code blocks that I have here, I have when the left arrow key is pressed, I'm going to execute a turn by moving the left motor forward and the right motor in reverse. When the up arrow key is pressed, I want both motors to go forward. When I press the base key, I want basically both motors to stop. And using the slider here, I'll just check out these other two. The right arrow key is pressed, I want the machine to rotate the other way, opposite to the left arrow key. And when I push the down arrow key, I want the machine to go in reverse. And then down here, I've got an eternal loop that will update my proximity sensors. I've got 4 proximity sensors. The 5th for some reason doesn't work. And I've got a shaft encoder sensor, and these are being reported in the corner up here. Of course, everything is being transmitted over wireless. So I have to plug that in now. I have a wireless USB serial interface based on the XB. Now, to make this all happen, I go into Extras, and I have to set my robot ID and let the machine know which one I'm talking about. And Marvin is currently set to number 5, where 5 is alive. And I also have to select the serial communications. Sorry, it was already set. Over here, I get to select which serial port it's on, and that is COM5 at this time. Alright, so I can get the Marvin to move forward a bit, and I can get him to stop. You'll see when I press a button that the block highlights itself, so you can see what currently is running. So if I use the up arrow key to go forward, you'll see that it outlines briefly, and if I press the stop button, you'll see that it briefly outlines as it executes the code. Now you notice up here that nothing is being presented. The code block for updating the sensors, of course, when the A key is pressed, and I put in a small delay there just to not saturate the airwaves. I can do this independently of actually moving, so I'll press A now and get it going. So you can see that it's going on a continuous loop, and you can see up here that the sensors are responding to whatever's around them, and the shaft encoder is currently registering the value 94. Now, I use the shaft encoder on an 8-bit value, so it'll go to 256 and rotate around, but I can use the delta to figure out how far I've gone. So let's turn this robot around a bit, and we'll go towards a wall, and you can see the shaft encoder here is changed somewhat. Now if we have the robot rotate, you can see as the shaft encoder is turning. You can also see that as the front of the robot rotates around and gets closer to the wall, that those sensor values should get bigger from the left sensor all the way through to the right sensor and then drop down again. Let's see what happens here. And there they go. So if we stop him for now, so we don't have to actually be driving this. We can write some code in there to actually drive it itself. But for kids, it's probably very much a lot of fun to first of all start with a bit of a remote control, and then figure out some way of building that into an algorithm that does something for them. So what I want the robot to do is map it's going to be mapping the room, and what the kids can do here in this space here is start with an initial position for the robot, say centerpiece, and use the pen function to trace its path. And after a while it should be able to figure out where the walls are in the environment, and then it should know that it shouldn't cross those, and it should also know what it needs to do, such as if it was a vacuum cleaning robot or a floorboard wallboard washing robot, it would have to actually do some wall following behavior.